guys, so today we're going to start working with Unit 5, so we're going to do Module 10. Lesson 10.1 is about comparing data that's displayed in dot plots. So let's get started. If we take a look at our Explore activity, dot plots, when you learn them back in 6th grade, they're pretty fun to make, they're easy to use, and what we're going to talk about today is how to analyze them. So we can use dot plots to analyze a data set, especially with respect to its center and its spread. So this is real. People once used body parts for measurements. So for example, an inch was the width of someone's thumb. In the 12th century, King Henry I of England stated that a yard was the distance from his nose to his outstretched arm's thumb. The dot plot shows the different lengths in inches of the yards for students in a 7th grade class. So, just for fun, the length from the kid's nose to their thumb is given by this dot plot. Very silly. But anyway, what we're going to do is we're going to practice analyzing. So, describe the shape of the dot plot. Are the dots evenly distributed or are they grouped on one side? In this case, they seem to be fairly evenly distributed. It's not perfect, of course, but we don't have like a whole clump of them all at one end. If they're mostly distributed evenly, or if they're mostly in the center, then you can say that they're fairly evenly spread out. So let's say the dots are fairly evenly spread out. Okay, I'm even going to add most are in the middle. So even though it is spread out, most of them are in the center there. Okay, so now we're going to talk about the center of the dot plot. Which single dot would best represent the data? So let's take a peek. We're looking at this data. Like we said before, it appears that most of the data is here in this center area here. Okay, so if we look at the dots from the ends and we come in to find the median, it would be right around here, around 31.5. So 31 has the most dots out of everything, but the center, I believe, is in between. We can look. If you'd like to, you could cross off the dots until you get to the end. I'm sorry, to the middle. And let's see where we end up. 31.5. Okay, so you can say the center of the data could be represented by 31.5. We can also say the center appears to be around 30 to 33-ish, 30.5 really, right? That's where it seems to be. Finally, describe the spread of the dot plot. Are there any outliers? Okay, if you recall from last year, outliers are the dots that are, or any data value that's way out there. Most of them are in the center, so an outlier would have to be really far away. In this case, we already said they're pretty evenly spread out, so there are no outliers here. Okay, so the spread is we're gonna say where it starts, where it ends. The data spreads from, and we can see that it begins at 28, so it spreads from 28 to 35. And then we want to say where most of the data is. With most of the data between, well, the majority of it's between 29 and 34, right? And we don't see any outliers. even though those two dots are a little farther away, they're not really that far. If you think about it, it's only one away. It would have to be way further away than that. Okay? All right, so we're not gonna do the bottom here because I want to move on with this. So next thing we're going to be doing is we're going to be looking at comparing dot plots visually. So without, excuse me, looking at two at a time and trying to compare their features. So we can talk about the center, the spread, and the shape, just like we just did with that one example, but we're going to be comparing two of them. So in our first example, we have two dot plots, and they each show the heights of 15 high school basketball players. I'm sorry, one of them shows the heights of basketball players, the other shows the softball players. So this is the softball players' heights, and this is the basketball players' heights. So first thing we're going to do is we're going to visually compare the shapes, okay? So let's do it like this: softball and basketball. Okay, so visually, what do I notice? Most of the data, well, not most of it, all of the data is 5'6" or less, okay? So there's nobody taller than 5'6". Okay, you could even be specific and say the heights. Basketball players, on the other hand, go up to 6 foot, right? But most of it is greater than what? Most of them are greater than 5'8". Kind of what you would expect, right? Most basketball players are pretty tall. Okay. Visually compare the centers. Okay, so now let's talk about the center. So for the softball players, if we're going to actually find the center, we would be crossing off, going to the end. If we want to talk about what we're seeing visually, it seems like most of the players are 5'4", so they're probably around there. So we're going to say the data is centered around 5'4". Oops, I forgot to write softball. Okay. And in basketball, the data is centered around 5'8". Right? Now, to visually compare the spreads, okay, we're talking about the range, right? So where do the heights start for softball? This is going up by 1 inch, right? So this is 1 inch less than 5 foot, so that would be 4'11", okay? And this one starts here, so we don't have to worry about that. Okay, so the softball players range from, so the spread, is from 4'11", and it goes up to 5'6". In basketball, the spread is from 5'2" all the way up to 6 foot. Okay, so as you can see, there's a greater spread in the basketball players. Okay. Now, if we're going to we wrote the actual data, so now let's actually come up with a conclusion for each of these. So, softball players, they're all 5'6" or less. The basketball players, most of them are greater than 5'8", right? So, as a group, the softball players are shorter than the basketball players. Or you could say the basketball players are taller. Okay, so this is our conclusion. Softball players are shorter. Let's write as a group here because we can't really make that conclusion even though it's mostly true. Than basketball. players. Okay. Now our conclusion about the centers of the dot plots. Okay, so this is what it's basically telling us is pretty much the most common heights, right? And we could also just see that by the number of dots there, right? The most common heights. I'm going to write SB and BB now because my hands are getting tired. Softball players is 5'4", and for basketball players, 5'8". Okay, and now finally, we already said this conclusion, but there is a greater spread in the heights for the basketball players. You could also say that the heights range more, or they vary more. There is a greater spread of heights on the basketball team. Okay, and those are our conclusions. So we're going to try the your turn. You guys can pause it and give it a shot. You're going to visually compare the dot plots of heights of the field hockey players to these ones. Okay, so you're going to compare them. So for the shape, okay, you're going to compare it to what these look like. You're going to compare the center, and you're going to compare the spread. Okay, so give it a shot and then come back to check your answers. Okay, so just comparing to the previous dot plots, the shape is pretty similar to the spread that we have for softball. The center, if you find it, it's 5'2", and that's less than both the softball and the basketball players, right? Because softball was 5'4" and basketball was 5'8". And then finally, the spread, like we said before, it's similar to softball players. It goes from 5 foot to 5'6". Softball went from 4'11" to 5'6", so it was pretty close. Okay? So let's move on to actually comparing dot plots numerically. So not just looking at the characteristics, actually calculating them. So we can also compare the shape, center, and spread of two dot plots numerically by calculating values related to the center and spread. So remember that outliers can affect your calculations. If you just look at this video game here, video game 1, all of the data is here except for 1. So remember that one value might really change the calculations that you do. So we're going to numerically compare these. So this is the number of hours that a class of students exercises each week compared to the number of hours that they play video games each week. Okay? Very interesting. So to compare the shapes of the dot plots, first and foremost, we're going to talk only in numbers here. So dot plots, they kind of look like they're complete opposites, right? So like the kids hardly exercise, right? This is the number of hours, but they're all playing hours and hours of video games. This is pretty realistic. So the dot plots show most kids exercise less than 4 hours a week, right? If you take a look, most of them exercise less than 4 hours a week, and most of the kids play more than 6 hours a week of video games, which is crazy. So we're going to use the numbers, okay? So most kids exercise less than 4 hours a week, but play video games more than 6 hours a week, which is no bueno, but that's besides the point. Now we're going to compare the centers of the dot plots by actually finding the medians. So to find the medians, we're going to cross off the numbers till we get to the middle. So let's just make sure if we have an even number, we're going to have to calculate that. So I have 1, 2, 3, 4. What does it say? Did it tell us? No. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have an even number, so we're going to have to get to the middle too. Okay, so we cross off till we get to the middle. Okay, we're almost there. So we have 2 and 3. So halfway between 2 and 3 is 2.5. So the average amount, not average, sorry, the median amount of exercise is 2.5 hours. And now let's find the video games. Same thing, it's going to be the middle two numbers. Okay, so that's just right on the 9. So I don't have to figure out the median because they're both 9. Okay, so the median's 2.5, the median is 9 for video games. So we're going to compare that. Okay, so the median number of hours students exercise is 2.5, so 2.5 hours. While the median for video games is 9 hours. That is 6.5 hours more. Okay, so you want to compare them. You don't always have to do that, but it's good to do that. Finally, let's compare the spreads by calculating the ranges. So to do the range, remember you do the greatest minus the least value. So the range for the exercise is going to be from 12 down to 0. So 12 minus 0 is 12. So exercise range is 12 hours. In video games is 14 to 0. So it ranges 14 hours. Okay? So the ranges are similar. The ranges are similar. With exercise ranging 12 hours and video games ranging 14. Okay, some things you could probably deduce from that too. You know, the kid that plays 0 hours of video games is probably one of the kids that does 12 hours of exercise a week, right? Okay. So I'm gonna have you guys do the your turn on your own. Find the median and the range of this data, and then compare your results to these. Okay, so give that a shot. Okay, so sorry I didn't say it specifically there. I want you to just compare to the exercise one, not both. So when you find the median, you'll see that it's 6, and then the range, the highest value is 11 minus the lowest value, which is 1. So the range is 10 hours, and this is for how much time the kids use the internet. So if you compare it to the exercise, the median was 2.5. So the median's greater than the median for exercise, but the range is less. So the range of hours was 12 for exercise. The range for internet is 10. So they're very close. They're very similar. However, it is less than the range for exercise. Okay, so that's it for today. Have fun with your dot plots.